When a nucleus gets too heavy, it starts to break down, and three things can happen. The easiest to understand is that small parts of the nucleus, 2 protons and 2 neutrons, break off together. This is called an alpha particle.
An alpha particle?
Yes, 2 protons and 2 neutrons. It's got a mass of 4 mass units and a positive charge. Now the next bit's really hard to understand, but bear with me. Remember those electrons you saw?
Yeah, where did they come from? They're still in the jar.
Well, it's a bit complicated, but it happens when a neutron splits into 2 parts, a positive part and a negative part. The positive part, the proton, remains within the nucleus, whilst the negative part, the electron, escapes. We call this the beta particle. It has a negative charge and a mass of 1/2000th of a mass unit.
So a beta particle is a negatively charged electron with a mass of 1/2000th of a mass unit? With you so far, I think. Just please don't tell me that the last one is even harder to understand.
No, this is quite easy. The third possibility is that some energy escapes. Just a wave of pure energy. No mass, no charge, just energy. We call this a gamma ray.
That's ridiculous. I've just done gamma rays. They were one of those waves in the electromagnetic spectrum, weren't they?
Yes, well remembered. That's exactly what they are. Come on, over here. Now, because these three things, the alpha particles, beta particles and gamma rays, are all made differently, they all behave differently.
That makes sense. Oh, look at the little fat alpha particle. He's not going to stand a chance against the energy of a gamma ray. Let's start the race. Ready, set, go.
Right. So the alpha particle is slow and lumbering. The beta particle is fairly fast, but the gamma ray is really quick. But that's not all there is to it. You see, these particles are dangerous. They're ionizing.
Ionizing? What's that?
That means that if they hit into other particles, they can harm them. Now look again. If we were to put them all into this ring, alpha would win hands down because he packs the bigger punch. The beta particle would come second, and gamma would be useless. But because alpha's so heavy, he finds it difficult to travel through other materials. If I put a paper bag over them, only beta and gamma can escape. But if I was to put an aluminium box over them, only gamma can escape.
So what stops gamma rays then?
Well, nothing really. A few meters of lead may reduce their numbers, but some will still find a way.
So all these amazing radioactive particles are just released by unstable atoms.